Today we discuss second chapter of second paper is conditional probability and independence. Introduction. In this unit we are going to discuss about the conditional probability of an event, independence of two event prior and posterior probabilities. First is the conditional probability. Let A and B are the two events defined on sample space zone corresponding to a random experiment. Then the conditional probability of event A given B is denoted by P of A by B. P of A by B, which is equal to P of A intersection B divided by P of B, where P of B greater than. Probability of event P given A is given by P of B P by A, which is equal to P of A intersection B upon P of B A, where P of A greater than 0. म्हणजे जर एक्झाम्पलमध्ये आधी बी दिलेला असेल तर ही कंडिशनल प्रोबॅबिलिटी वापरायची आणि एक्झाम्पलमध्ये आधी जर ए दिलेला असेल तर ही कंडिशन प्रोबॅबिलिटी वापरायची एक्झाम्पल सॉल्विंगसाठी. Next is the example. The probability that a research product will be well plain is 0.8 and the probability that it will be well executed and well plain is 0.72. What is the probability that a research project that is well plain will also be well executed? So there is a two event A and event B. Event A is research paper will be well plain and event B is equal to research paper will be well executed. So event A is what? Research paper will be well plain. Here probability that a research product is being well plain. Research product. Here P of we have to given that P of P is equal to 0.8 and the probability that it will be well executed and well plain. So P of well executed and well plain, which is equal to P of A intersection B is equal to 0.72, and we have to calculate P of B by A, which is equal to what? So P of B by A is equal to P of A intersection B upon P of A, which is equal to P of A intersection B is 0.72 upon P of A is 0.8, and after solving it we get 0.9. Next, example. If the probability that a communication system will have fidelity is 0.81 and the probability that it will have fidelity and high selectivity is 0.18, find the probability that a system will have high selectivity given that it has high fidelity. So here is also two event. First event is a communication system with high selectivity, and B is a communication system with high fidelity. Here communication system will have fidelity 0.81 is the probability दिली. So P of B is equal to 0.81 and P of high fidelity and high selectivity is equal to P of A intersection B is equal to 0.18. तर आपल्याला इथं पहिले काय दिलेलं आहे, बी दिलेलं आहे. तर आपल्याला कोणता फॉर्म्युला वापरावा लागेल, तो फर्स्ट फॉर्म्युला वापरावा लागेल. सो पी ऑफ a system will have, we have to calculate, the system will have high selectivity given that it has high fidelity, which is equal to P of A by B, which is also equal to P of A intersection B upon P of B, which is equal to 0.18 upon 0.81. After solving it, we get 0.2222. So next is the multiplication theorem. If A and B are two events defined on sample space O, then the multiplication theorem is what? P of A intersection B is equal to P of A by B into P of B, where P of B greater than 0, or P of A intersection B is equal to P of A by B by A into P of A, where P of A greater than 0. This theorem is also called as compound probability theorem. Next is the Bayes theorem. Statement of Bayes theorem. If A1, A2 up to An represents the partition of sample space O and B is any arbitrary event, then B is a subset of union AI, where I is running from 1 to N with P of B greater than 0. Then P of AI by B is equal to P of B by AI into P of AI divided by P of B by A1 into P of A1 plus P of B by A2 into P of A2 plus so on up to P of A by An into P of An. So using this formula, using this statement, we solve one example. Example is the events A1, A2 and A3 form the partition of the sample space if P of A1 is equal to P of A2 is equal to P of A3 is equal to 1 by 3, and P of B by A1 is equal to 2 by 7, P of B by A2 is equal to 4 by 9, P of B by A3 is equal to 1 by 5. Then find the P of A1 by B. So by Bayes theorem we have P of A1 by B is equal to Bayes theorem, P of A1 by B is equal to P of B by A1 into P of A1 divided by P of B by A1 into P of A1 plus P of B by A2 into P of A2 plus P of B by A3 into P of A3, which is equal to P of B by A1 is 2 by 7 into P of A1 is 1 by 3 divided by P of B by A1 is 2 by 7 into P of A1 is 1 by 3 plus P of B by A2 is 4 by 9, P of A2 is 1 by 3 plus P of B by A3 is 1 by 5 into P of A3 is 1 by 3, which is equal to 2 by 7 3s are 21 divided by 2 1s are 2, 7 3s are 21 plus 4 1 जा 4, 9 3 जा 27 plus 1 upon 5 3 जा 15. After solving this, we get 0.3072.